They are now in this situation with the output from these devices, building or not building their knowledge. We need to consider, is the output from this tool, is it telling, guiding, building knowledge, or opening up? And students, if they can spot that, they will take different action. Similarly, there's this idea that of feeding forward, something I've not talked about in this presentation because we don't have time, but this idea of, well, how do students then move that into their next learning? And then as educators and designers of tools, then we need to consider how we design the overall learning experience for students so that they understand the output is feedback from these devices. And definitely within application design, this idea of feedback literacy needs to be considered. So I'm just going to finish my last little bit. There are emerging findings that using generative AI tools in classrooms can lead to equity issues. And what that's the emerging finding is, if you're a more experienced student who already is making good progress, then AI tools to help you learn will make you learn better. But if you are a student who's maybe struggling, then it could be, or the evidence seems to suggest, that it can actually make your learning worse. And that's a bit scary. And that, well, why might that be? It seems to be that students with less experience, they don't really understand the output that they're going, nor of their role in terms of using the feedback. There becomes an over-reliance. There's also some emerging research around reducing critical thinking and problem-solving skills because of this idea of what's called cognitive offloading. And especially if you trust an AI application, then you're more likely to offload, and that can lead to this idea of cognitive laziness. And so, but as teachers, as we're designing these interactions, we can be aware of this and we can take action. So we need to teach students how to use these tools, including one really important thing that's coming out from the research in terms of programming, teaching programming with AI, is to decompose problems. So teachers, you can consider feedback literacy. You can redesign, in a sense, how we teach programming and other lessons using generative AI. And maybe some of these new tool options are going to help us as well in that. And I just wanted to bring your attention to the work by Leo Porter and Dan Zingaro in America. They presented at I mentioned before we do these seminars, and they presented at one of our recent seminars. And they have extensively used co-pilots in their undergraduate teaching of programming, but it is to novice programmers. And they've come up with this new pedagogy, this new workflow for teaching programming. And what's interesting is they've kind of added on this, you're helping students to break down a problem, designing prompts, generating code, reading code, but this really big, important part of testing and how that's kind of becoming almost more of a test-driven kind of paradigm to problem solving. I don't work for these two academics, but I think that they're onto something, and it's something that we're looking at in terms of our own research. So we've done all three bubbles. If you want to look at any more of our work in terms of research in this area, as well as products that have been developed by the foundation, we've got the Experience AI lessons, we've got an introduction to data science, we've got all sorts of kind of Key Stage 5, that's the older learners, 17 and 18-year-old stuff. We've got non-formal learning projects, And as well, we've got much, so down the bottom is all the research that we're doing. We've got lots of work that's all around research, including some really lovely work that's been done recently by one of our PhD students, where she's looking at unplugged ways to teach about AI in Ghana. But anyway, lots of things if you're interested. Very long list of references if anybody's kind of into references. And that's me finishing. I've got a few minutes, a little bit of time for questions, and thank you for listening.
Can you hear me?
I can.
Okay.
Hello.
Hello.
All right.
No, yeah.
Okay. So, Jane, thank you very much for that wonderful talk. I'll first open it for questions. Could you please just quickly introduce yourself, name and ask?
Am I audible? Hi, Dr. Waite. I'm Ashwini from an organization called Educational Initiatives. So I and my colleague Bharat here are from the computational thinking team. So a trend that we've kind of been seeing across schools is even say 5 or 6 years ago, there used to be this focus on teaching a lot of tools in class. They would teach image editing and video editing, and now there's 3D printing and robotics, and now a whole host of AI tools. How do you see this move from teaching how to think about technology and now this move towards teaching tools which may not even exist 10, 15 years after because they're changing so quickly? So how do you see this trend and what, according to you, is the right way forward?
I think that's a wonderful, wonderful question. Ashwani, sorry, I wasn't sure I got your name. Anyway, but it was a really good question. I can't hear you now for some reason, but anyway, can you hear me? Yes? Someone give me a thumbs up if you can hear me. Yeah, okay. I think it is about computational thinking 2.0. So just as you've been very effectively, or it sounds like you've been effectively introducing computational thinking in the introduction of tools, so can we do the same as we move to AI-based applications and introducing this new version of computational thinking? So that there is going to be issues around bias, that there will be issues around accuracy, that it's about the data that was used to train the model rather than it's an explainable algorithm. So I agree completely that often tools are taught before the underlying concepts, but it gives you an opportunity to start to get students to question, well, how does this work? Is it always accurate? Should I trust it? And it sounds like in this community, the CTiS community, that computational thinking is the thing you're using to help people move from tools to concepts. And I think that's exactly the same. Do the same, but bear in mind it's a different CT. But I don't think as researchers or as a community yet, we really understand what CT2 looks like.
Thank you. My name is Ramanujam and I'm a teacher and educator. My question is, I have a couple of questions related. One is, I like the CME framework very much, but it still leaves the question about why we are teaching about AI at all. Is it, or is it just the question is too late and we have got to do it? Is it that, or so? What would be the curricular or pedagogic objective of wanting to teach these? And then, because it's about how to do this, but why are we doing this? And then in CT 2.0 as well, if we talk about data-driven approaches. It's true that we want to look at data and build models, but that's what we do in science and science education and probability or data handling in mathematics. We do that. But the differences in AI, the models are not built by human beings, but machines learn the models, right? Now, if we are going to teach children to look at data and build models on their own, how is it that they're going to get insight into, or should they need that insight at all about how machines learn those models? So I'm just asking more from an curricular objective of what we are about. Yeah.
They're wonderful questions, and they absolutely go to the heart of the issue. It's, well, why do we want children to understand how their world works? They don't need to. Potentially, some people might argue that they just need to use it. So it goes back to the tools question. But I think over time, we've decided actually understanding how something works helps us be more critical as users. So my view is we do need to go under the hood, and that's not just so that people can become developers, but also so they can become more critical consumers. And also they can have agency to say yes or no to these tools being in our society, and to understand those who will be most disadvantaged or who will be advantaged by it. So I completely agree. Why bother teaching about AI? It's in our pockets. It's already here. There are sprinkles of AI in almost every tool we use. And these products are being used to make really important decisions about our lives. And without that ability to critically engage and have agency to understand and then act, I think we're doing a disservice. And potentially, and it's about inequity, because potentially those students who are going to be most disadvantaged by AI output are the ones who will have least agency because they have least knowledge and maybe will learn less effectively. So I think the cat is already out of the bag. I agree, it's a philosophical debate. My view is we just need to teach the kids. In terms of curricular objectives, there are growing curriculum frameworks. I think the UNESCO framework for students is probably the most comprehensive we have right now, but I know that there are others, and we're doing work in that area. And in terms of your question about CME, it's just a way to get going, but for us to make sure we don't forget about the social and ethical. Computer scientists, I'm a computer scientist and I'm an engineer as well. I like to make stuff, so I end up going down the stack. I'm interested in the engine and the model and the application, but the social and ethical issues are so important. That's what CME is about. And in terms of, then you asked about what is it that children need to know? Do they need to go all the way down effectively, how far down the stack do they need to go? I think that's a really important question to ask about progression, because they just have to take it almost by faith if we say, don't trust this. And then we fall into the anthropomorphization, and it's, well, why shouldn't I trust it? And I think there's a risk if we don't at least expose some of what's inside the black box. Maybe they don't have to learn how to program and create their own models, but we can use low code, no code, unplugged activities to demonstrate, just as with the parity checking, that sometimes things do or don't work. And actually there are reasons why these tools will give different outputs and sometimes will be biased. And if you understand that, then maybe it's more memorable and maybe you'll have more agency. And that was a long answer, and I'm sorry.
I'm audible. Yeah. So, Doctor, I have a particular, I'm PhD student in mathematics at IISA Pune. So, I work in abstract area called topology. So, I have a question related to that. So, a concern what I see teaching using AI is like students lack creativity. I do teach some with some NGO at schools also, and then bachelor students, master students. The problem what I encounter is, for example, the student these days, if I ask, okay, plot z is equals to x square plus y square, they will just rather than doing it with hand, they will use AI software or chat GPT, like these kind of platform. So what I think, they sort of lack creativity, and in some areas of mathematics you need that intuition. You should work on your own rather than because computer cannot help everywhere in like my area topology, but uh, this is also like an important area, and there is many intersection these days, like data analysis and also like how to like face these challenges, or like what we can do.
That's a wonderful question. Again, a really good question. Thank you for asking it. And that goes back, this is a bubble that is all about using AI to teach. And the work of Leo Porter and Dan, I think, speaks to this, but they've addressed this from a programming perspective. And what they've found is they can't ignore AI as in teaching and learning. It's here, students will use it, and we know the risks of cognitive offloading and this cognitive laziness and this idea that some students are losing their ability to think critically and also for problem solving, and there is building research that's giving that as evidence. And then as teachers, it's about pedagogy and content. I think teaching students their responsibility as a learner, about feedback literacy. You're just being told you're not learning. How do I help you develop knowledge? So teaching them about feedback literacy, and then working out how, as Dan and Leo did, how do you change what you teach? You helping students to know how to use generative AI ethically and with principles. In fact, they need to use fat peas. They need to be fair to themselves to learn. They need to be accountable, transparent, maintain their privacy, maintain their safety. So fat peas is about productivity then for them to learn. So there's kind of a merging. So I don't have all the answers, but I would say it's a problem for every teacher in every discipline right now. And we need new pedagogies. And I think feedback literacy is important. And I think Dan and Leo's early work is useful as an example.
Thank you. I think we are running out of time. We have probably time for one final question if anybody has any question. I assume there's no question online. I just checked with Pratisha. Last question.
Hi, this is Soham from Quest Alliance. So I think you talked about the critical part of the AI and and also you were saying of the CT 2.0. Speaking of the data sets and kind of working with them, I think that work comes with the trust factor, the ethical part with AI or any of those, the accuracy part. And kind of maybe after 10-15 years down the lane, the technologies might change, but the kind of the critical part of with AI or any of those, shall we kind of start before we talk about any of those tools? Should we also start talking about digital citizenship in our schools first, and then kind of because with any tool you might talk about those ethical part and everything, but kind of, but the idea of more of digital citizenship, that how when I kind of see things, I do not start believing in things, and kind of, or I start kind of questioning it first, and then I move forward to any of those tools. Yeah.
Again, you're doing the presentation for me. That's exactly what I think. It's great. It is CME start, the social and ethical aspects of the work we do as computer scientists has in the past been overshadowed by a view of technology and algorithms. And now the impact of these tools is so profound, we can't ignore it. So I completely agree. Teaching about citizenship, teaching about critical agency, transformative agency, so that students can make choices and say yes or no, because they understand the application, they understand the model, and they understand a little of maybe how the engines work. But yes, I agree. Social and ethical, it's absolutely key to all of this.
Thank you very much, Jane. Jane, you earlier spoke about tradition when you spoke about Sue joining us last year. Let me just share with you that Paul Curzon also had joined us a few years back, and she had talked about semantic waves. So we're just continuing the tradition here. But
Yeah.
thanks again for that wonderful talk. And please, all of you, please, if you can join me in thanking her. Really enjoyed the talk. Thank you. We will be now breaking for
next presentation.
Oh, I'm sorry.
Welcome. One second.
We have next two presentations coming up on the theme CT and science education. So I request Shivjit Singh, Gajendra Singh, and Upendra Pal. They are from Rajakiya Ashram Paddhati Inter College, Hardoli. Please. Next presenters. That's what I said. You have, right? Yeah. So use this as it's like next slide, okay?
So, very good evening to everyone. I know many of you are expecting a tea break, and I was too, but let's go with the presentation, right? Ma'am, one thing I just want to, I was sitting at the last, and one thing I was facing a difficulty is that the picture is not that contrast. So I think the characters are not legible, if I am correct with the last people, if they compare with me. Characters are not legible. So if you can increase the contrast, so they can see the words. Because my presentation is not too much attractive, I know, but the content there is a bit of fabulous. So I want to share with the audience. So yeah, light closing will also work, I think. Yes, definitely. So my name is Shivjit Singh. Along with my co-authors, Gajen Singh is there and Upendra Pal. We are from Rajki Ashrampati College, Banda, Uttar Pradesh. So first of all, before starting with my presentation, I would like to extend my heartiest thank to CTiS community, TCS, CSpathshala, ISER, and all those people who are behind the curtains who put up this platform for educator like us, for all the peoples from the different disciplines, professionals, researchers to come and collaborate over here and discuss their viewpoint and how they are contributing to the city in their education part, in their schooling education. So without wasting much of time, I would begin with my presentation. So title of my presentation is it basically belongs to the chemistry title. So it is unlocking chemistry with the. Is it not working? I think. Yeah. So my title of my presentation is Unlocking Chemical Mind, Computational Thinking as a Catalyst for Understanding. So, so can, yeah. So computational thinking as a catalyst for understanding. Yeah, you can go on with the next. So here I have just I will be discussing few of the activities that I have done in the schooling part, and children had get a lot of it. And I was also the part of the CTiS event last year also. And I see when the terms computational thinking comes, no, most of the activities or unplugged activities comes from the part of mathematics or from the physics. But I am from a different view that I have created something, some point with the chemistry also. So my first activity is deconstructing the invisible. Now, as the name suggests, deconstructing. Here will be here the child will be decomposing the unknown sample given to him, and the activity goes like that. This is suppose it is a class, and the child, one of the child who will be contesting, will come up over here, and he will be given an unknown sample. I will give him an unknown sample, and he has to face that sample upfront in front of the spectator children. Now the thing is that the child that will be holding the sample, he doesn't know what chemical compound does it have. So he has to ask some questions to the audience. Now the rule is you cannot go with the random questions like what compound I am getting. No, the rule is that the question you can ask is based on the uses and properties of that compound, right? And now how CT is involved, that one more rule is there, that the answers would be coming in the yes or no format, like our computer does. Computer takes the form of the binary language 0 or 1. Here 0 is yes, 1 is no. So suppose how this activity works, I'm going to tell you that suppose I'm holding a very common compound, most of you know it, like NaCl, so sodium chloride. Suppose I'm holding it, right? And I don't know I'm holding a sodium chloride. So I will say, I will ask you a question that which color does it compound have? So the people, no, I will say that is it a white colored compound? The answer I will get in a yes or no format. If it yes, I will deconstruct that. Yeah, white color compounds. What I have heard, what I have learned, white color compounds. It might be a bleaching powder. It might be a sodium chloride. I will guess it. I will deconstruct my answer. The second question I will go on with that is it a commonly used salt? We know that sodium chloride is our tablespoon salt we use commonly in our day to day. So I will deconstruct it. Yeah, the second point I deconstruct that. Yeah, it is a commonly used salt. In the third, is it prepared by some method like desalination of water or by osmosis process? If it works, if the student says, if the spectator, you audience says yes, it is, then I am ready with my answer that I have deconstruct what unknown salt I have containing. It is sodium chloride. So I've just taken a simple example, but think of how interesting it becomes when it is integrated with their curriculum part, students part, and I have given them the compound of the class 11th or 12th what they study in a syllabus. Now they have to deconstruct them. So it becomes difficult also. They have to encroach all the debugging part, the troubleshooting, and have to critically analyze the data that yes, what yes or no format, and he will go on with the answer. Now, the student who will able to deconstruct the unknown compound with the least number of question is the winner in our activity. And we used to do this activity in our classroom, and we get a very great response because yeah, we had a contesting spirit in ourselves that we also like to win, right? So student also had a very good spirit over them, and they take a part in those activities very firmly. So there are just images of that how this activities was done in our classroom part. So can we move on to the next slide? Yeah. I think pen is not working. You can do it with the, yeah. Next. Yeah. Just, yeah, this is how, yeah, you can see the child holding the sample of the compound he has given to him, and he will be asking the question to the spectator and that in the yes or no format. Remember, the language is yes or no format. Okay, I'm also running with a short of time. Then my next activity is the gridlock puzzle. So move on to the next slide. The gridlock puzzle I have created it is very interesting. things. If you have a very simple sound of language, sound knowledge of chemistry, then I could able to help you explain what my grade log challenge work is. We all know functional group. Might be have heard in any of your previous knowledge of your schooling. You might have heard of alcohol, ketone, carboxylic acid. I think most of you have heard it, right? These are the functional groups, and we know that they are interconvertible, right? Okay, so they are interconvertible. So in the next slide. So there are the nine methods by which 8 methods by which they can be interconverted. So these are the methods. I'm not going into detailing because I'm not teaching chemistry, but it is these are the pathways by which they can be these grid logs can be interconverted. Now, can you show us the grid? Yeah, this is the grid. Now here also in the horizontal row we have an functional group. In the vertical column we also have a functional group, and few of the hints are filled. Now the rule is, among those 8 reaction pathways, that paths that we have chosen, you cannot use one pathway more than once in a single row. That rule is, you cannot use one pathway more than in a single row. So when you like here, if I have used this particular pathway once, then I cannot use it in a second method. Now, if I go on with the next, if this child has chosen that, yeah, we can convert alcohol to carboxylic acid by this method and by ketone with this method. So, see, how can we convert? This is the first pathway. And if I go and go on with, if this is eligible enough, he can go on with this pathway. Now, here he have to go with 3 steps. Here, 1 step is involved. Now, the slide is empty. Yeah, and just I'm going on explaining. Now here he is going with the 1 step, and here is going with 3 step. But if he have interchanged it, if I have gone with alcohol to carboxylic acid with water and alcohol to ketone with $O, then this complexation has been reduced with the 2 steps pathway. So think, this is the interpretation, that this is the critical evolving, that the child has to think that which reaction pathway he which has to choose. And now coming on to the outcome of it, do you believe that if he has solved this 8 into 8 crossword puzzle, how many reaction he has to go through it? 8 into 8, 64 reaction with a single puzzle he will be able to evolve out and come out with it. So this is the beauty of this my crossword puzzle is I could solve out. So just a second, one more minute if I could take out, borrow out. And the next of my activity is that molecular simulation, visual simulation that we have created, but due to some technicalities or glitches, I could not able to show you out. But those molecular simulations, we all know, there I have created. We ourselves have created some games like seesaw games that we see in a schooling part, and their student used to solve them and able to crossword with the things, right? So just due to lack of time, this is all about my presentation. Now, any question if I'm open with it? Any question, anyone? All right, fine. Thank you.
That's interesting. I think you can interact with and show your games. Thank you so much. Next presentation is from School of Scholars Subardha, Sarita Satone and Vrishali Date.
Good evening, everyone. I'm Rishali Date.
I'm Sarita Satode. We are science educators from School of Scholar Vardha.
Today, we are presenting our topic, Exploring Motion Pattern through Computational Thinking. It is implemented for grade 6 and 9th.
At our school, students struggle with the concept types of motion. Despite of textbook definition, they found it difficult to visualize and relate the concept with a real life application. Around 65% of the students face difficulty. So we shifted our approach and we designed activity-based learning integrated with the city skills.
In our first task, we introduced paint box motion activity, which beautifully merged art with physics. In this activity, students has used a paint box suspended with the strings. As you can see in the image, students are pouring paint into the box and move the box, which results into the beautiful patterns on the floor. So while performing this activity, we are encouraging students to not enjoy the patterns, but concentrate to connect it with the real life motion. So they had connected it with the real life motion, like swinging a pen box with the pendulum or swing, and even the splattered pen with the random motion of the dust particles. So by creating the patterns, analyzing them, and finally connected it with the real life application, they had understand the concept step by step.
We also encourage students to break down the concept into simple parts. And also, we didn't just ask them to identify the types of motion, but we guided them to analyze it. What type of force acting on it? What is the direction of the motion? Is the speed changing or remains constant? So this helps them to link force, speed, direction to explore the motion concept. And again, they also started thinking about what the pattern look like, which type of where they had seen before, and this helps them in learning experientially relatable and interactive. Again, we also form the groups of the student where students explore the motion in collaborative and creative tasks. They uses pen brushes, droppers, rotating device to create and recognize the motion trails.
After these activities, students compared their outcomes and classified the patterns with the different types of motion, like a car for the rectilinear motion or the ferry wheel for the circular motion. Even they had observed students playing hula loop on the playground and identified it as a circular motion, or the student playing on the ground as a random motion.
We also explore the we also explore the motion by using the laser pendulum activity, where the students suspended the pendulum laser pointer, asked them, allowing them to swing, and also observe the reflected paths in the mirror kept below. This activity visualized the linear, circular, oscillatory, and complex motions by depending upon the how the laser pointer moves. And again, in the we also integrated the fate simulation online digital tool wave on a string, where the student changes frequency and amplitude to explore the oscillatory motion. And again, by using this fate simulation digital online tool, they explore the simple harmonic motion.
Actually, we had added here one video which might be run, ma'am, if it is.
No, start next.
Okay, fine. We are going to next slide. Peer discussion helps students to boost up their confidence and even improve their application skill. This discussion cemented the connection between theory and the real life world. So, which helps to deepen the conceptual understanding of the students.
But of course, we face some challenges also. Uneven flow of the paint due to the uneven surface issue. Then again, laser sensitivity problem also, and unstable setup of the pen box. But we resolve this issue by group monitoring, tool calibration, and encouraging the peer discussion and observation. But the best part, these challenges become learning opportunities, and student applied the logical thinking and teamwork to overcome them.
The impact was powerful. Actually, both the activities shifted students from passive learning to the active exploration. Concept clarity roses from 35% to 85%. Students those are actually they are means memorizing the definitions of the motion or the concept related to the motion. Now they are starting to apply the computational thinking skill to understand it, so their confidence, engagement, and the application skill has improved significantly. Combining hands-on activity with the computational thinking makes science more engaging, visual, and memorable.
These activities help them to explore and see the motion, action in motion to by the simple experiment and hands-on activity and real life activities also. And student actively develop the CT skills in them, that is abstraction, logical reasoning, and pattern recognition.
Predicting motion effects encourage algorithmic thinking in students. And now students have started to apply this computational thinking in other science topics also, which make their learning more interactive. Thank you.
Any question? You can use that. Yeah. Since from the morning we are talking about computational thinking and unplugged activities, and I think that's the approach taken up by maximum teachers in this process of teaching and learning computational thinking. When we have received so many abstracts and the review was done, there were a lot of activities, there were a lot of abstracts based on unplugged, and that's why there is a demo session on the second floor and poster and demonstration, and this covers lot of unplugged activities across various subjects. So the we break here for tea, followed by a poster and demo presentation on the first floor in the same building. Thank you so much.
आप लिखना शुरू कर दो जो Savita ma'am, please release the meeting now.